guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. I'm just going to keep repeating this over and over and over. This is my mantra for this video. It is not my job to talk shit. It's my job to repair the amplifier. Now, you will not, through this entire video, hear me say a single negative thing. That's not the way I work. That's not the way I am as a human being. That's not the way I feel. It's not the way I am. I personally don't believe that that's productive or helpful. I'm going to say this. I applaud my customers. And I applaud you guys because you're actually smart. If we teach you something or show you something and then you guys go and apply it, you know, and put it into operation in your side of the street. You guys are quick. You pick up on things, right? So what I've done is I've created an army of watt watchers, okay, meter watchers. I've got you guys thinking forward power, reflected power. So if the RF is coming back to the box or the radio or it's not going out the antenna, there's a reason why. My guy that owns this amplifier, he's a smart man. Okay, he's incredibly successful, runs a large company. He's got lots of people that work for him, and he's quick, he's observant, and he's smart. And he went and he purchased this amplifier because he's a collector. He collects from everyone. He's got them all. He's got the Fat Boy. He's got the Dave Made. He's got the X-Force. He's got the Tech Nines. He's got everybody. And not like just one, but like literally one of every single thing that they make. He is your dream customer to get because he will spend gobs of money on your product line. And he gets it on his end and he'll play with it. That's what collectors do. And this particular unit, he started purchasing his way through the Donkey Stomper line, and he got up to this 2x4 that we're going to look at here today, and he was immediately on the phone. He goes, "Man, I got a problem." And he goes, "What would cause my reflect to jump up from, which is normally like 1.5 watts with about 7,000 bird going out, to all of a sudden like almost 1,000 watts of reflect?" And so we had a conversation. And so I have to show this to explain what's going on. This is my spectrum analyzer that has been provided to me by Siglent. I'm currently getting, I get new firmware for this, like usually bi-monthly. I'm their test guinea pig. This is the most, I swear to God, I've had probably 8 different firmwares in this particular meter since I've had it. I don't mind. I think that's great because all the new stuff I get, I come out here, I play with it, I find a bug in it, and it locks up or bricks or something. I shoot them a video of it, send it off to them, either send them the unit or they send me another one or they send me a new firmware with a patch in it, which is kind of cool. The advantage of that is that you get to stay on the modern edge of the unit of measure, and so it's very accurate. I got to explain to you what we're looking at here. So you're looking at the entire HF band. We're looking from 56 megahertz to 0 megahertz. Okay, so 0 megahertz, 56 megahertz. It's also shown over here. Start frequency 0, stops 56, our center's 28. Okay. Our offset 0, frequency stop 1 step, signal track off, peak off, so on and so on. Let's go look at amplitude. Our reference line is negative 2.5 dBms down. I leave it like that because I don't like to look at all the hash signal at the bottom of the noise floor. I like to leave it just where I'm seeing just the tips. Just the tips, Sally, just the tip. We got a negative 31 dB attenuator going on. Plus then that sits behind a 15 dB attenuator that's also attached to the meter. And I do that because I'm running a lot of power by it. My pickup is off the Bird 43 line section, which has also got itself itself is a 15 dBm down attenuator. This thing's so sensitive, it doesn't matter if a titmouse is farting in a field trying to work as man animal, this thing will see it. Our scale's in 5 dBs, blah, 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 blah. This isn't going to change. Now what I'm going to shoot now is a non-stop video. We're not going to cut away. We're not going to move anything. When I go and I key the amplifier, I'm going to show you both hands. I want to show you something. We've got our signal that's on frequency, our principal. And it's very rare that we see the amplifiers that come through here that are adjusted, I think will be the term that I go with, adjusted like this, to where they will create gobs of false signal, false power, stuff that's way off frequency that we can't use. So I got to be very careful what I do here. Now the last two donkey stompers I worked on, the 2x6 and the 2x8 that have recently been here, and they both had the same characteristics to them. The customers have got them back, the problems have been overcome, they're enjoying the power of the box, and the boxes are running great. So we're going to run through this thing top to bottom. But this is going to be our main source of demonstrating to you what is going on, not the watt meter. When we come back around, we're going to do spectral monitor. And just to kind of get your brains used to this, this is a decadal display. It's showing everything that's happening from the bottom up. So whatever gets presented here is signal. That's our principal of our radio. Shows up here with a color band. Blue is zero signal, or what we consider to be zero signal, at negative 52 dBs. An incredibly strong signal is going to be at negative 2.5 dB and below zero. Now, as we proceed forward, what we have to keep into mind is that anything that occupies more frequency than the width of this pen is considered loss, waste, not useful, doesn't help us. No one's going to hear it. It's going to show up out of frequency, and it's going to come out as reflect. The power that is getting produced by the box will show up on our reflect meter because it's not going to be on our resonant device, which is called an antenna. Okay? The mother of all chokes, your antenna. It's another long conversation that we can have about how certain radio operators in a certain club, usually involves a call sign, carry on about how people are splattering 90, 1,000 kcs wide or whatever. It's not physically possible to produce that signal because the antenna is not physically able to be resonant that far. It will show up as reflected power. So, i.e., the reason that you're receiving this person is because their signal strength is so strong and that it's overloading your receiver. So quit using that terminology. It makes you look like an idiot. Period. In reality, this is the total amount of frequency occupation for this particular piece of equipment that it'll be used upon. This is how much signal, the width of the pen tip is roughly how much signal is shown up that can be utilized in someone's receiver, roughly about 5 kcs. Okay, now we got that all figured out. Let's go ahead and just zoom on out, and that's all we're gonna do. And I want to pan down here, and I want to show you the radio, and or show you the amplifier. There's our principal. Make sure both my hands are in frame. They are, on key. The second order harmonic that is up here, we need to pay close attention to. This is not the worst one I've ever seen. I have seen way worse than this, but this is pretty bad. And it continues on and on and on. If I was to pull my attenuators out of line, I could probably be able to detect this amplifier making signal all the way up to almost 100 megahertz. Okay. Now what we can look at over here is this is our our meter in 1000 watt peak, average in 5 watt reflect back from the bird, 10,000 watt. Let me load. Wow. It's still all over the frickin' place, and we're making about 700 watts of power. We can look over here at our amp gauge. Wow. Making about 88 amps, drawing about 88 amps, only making 700 watts of power on 14 volts flat. Let's go over here and look at the spectrum analyzer one more time. I like the waterfall measurement. It allows us to see a whole lot of characteristics in the carrier that we normally wouldn't pick out with our eyes unless we're slowing down to look at it. This is our principal here. At least we have the primary amount of amplification somewhat taking place on the principal frequency, but our second order harmonic going farther forward in spectrum, we can clearly see by color is stronger on this signal. Of course, we can also see that represented on the spike there on the carrier. So now what we can do, this is kind of slick. So how do I show this? By changing our drive level, I can take the variable on the front. By changing our drive level, you see that? We can split our levels of harmonics just by changing our saturation level of the device and of the cores and of the circuitry. Which when I see that take place, I know exactly what's wrong with a piece of equipment. When I first bought my very first spectrum analyzer, I was so excited. I'm beyond happy with myself. I paid $700 and some for it. I bought it in Elko, Nevada, and I was so excited. I was driving home with my wife. We had it in the back of her Ford Explorer at the time, and I kept saying to her all the way home, I have a spectrum analyzer. I'm so excited I got a spectrum analyzer. And then I came home and proceeded to put myself through idiot school. Once again, completely self-taught on a lot of these things. Some of these things, most of these things, some of these things. I came home and I had a X-Force Carl made X-Force 2x4, and I proceeded to change every single thing in that box and watch how it changed my signal on the spectrum analyzer. I mean, I spent like a week dicking with that and taking note after note after note after note after note. If I change this cap here, this is what the signal characteristics look like over here. My Bible. It's one of about 5 I've got. That's the one that specifically deals with spectrum analyzers. And what this particular device looks like here and what we've got to do to change here to make this right, or what happens when I change this. This is how it shows up over here. My job's to fix the box. We're going to do that by changing, just to get it on frequency. I know for a fact that I'm going to have to change 1, 2, 3, 4, 5 caps in this thing, and it'll probably settle right down. So let me bring the camera around. Sorry, this particular lens does not have image stabilization on it. It's one of those things that we're going to buy in the future. I got tired of spending money on this camera and on this YouTube thing, so guess what? I bought my wife a new bed. I put some new tires on her truck. I bought her a new phone, and now I get to go back and get to spend money on the camera thing again. So the next thing up is going to be image stabilization for this thing and a more aggressive focus. Okay, let's go take a look at the inside of this thing. There's a couple things that stand out to me right away. These old tired eyes of mine. These old tired eyes of mine. I'm gonna let it shine. Okay. First thing is we've got all of our input signal going through a 50 ohm load voltage divider. That's about 50 ohms is a voltage divider. Which tells me that the original builder had a great deal of input reflect, and he couldn't figure out why, so he just put a resistor in its place and put it behind it, a voltage divider. There's not enough turns on this input transformer. Our output transformer has too many turns in it. this one here. This capacitor here, if you guys want to stand on your head, that's a 220 puff cap. That's something that we've seen in the last 3 boxes. This is a 220 puff cap, this is a 220 puff cap, and this capacitor here is a 240, which for HG 2879s is too high. This one here is 180. We need to change that to 150 to make it electrically resonant. And then let's go over here. The crux of some of the problems is the induction difference between the input splitter and the output combiner, and the number of turns ratios in the output combiner. We've ran into this 3 donkey stompers ago. Also where we end up putting the capacitance, at least we have modified, and now it's attached over here at the output. We are using a capacitance tube, which is a step forward, but I have a feeling that this is also in the wrong place, but that's okay. We're gonna go fix all of this stuff. We might end up changing this combiner setup here, depending on what it does once we fix all of this. Our saturation issues, and the reason we're seeing our 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 12th, 13th, 14th, and 15th order harmonic between 0 and 56 megahertz, all has to take place with this here. Remember, an amplifier can only amplify what's put into it, okay? It's very hard for it to be so far out of whack that it's going to create out of resonant signal. If you have this particular stage creating a ton of harmonics, this particular amplifier, because remember there's 2 amps in here, the driver section and the final section, this will only amplify what you put into it. So if you shove crap into it by having a completely out of resonant drive section into a final section, it's going to amplify this crap. So I'm probably going to take a hoop out of here. I'm going to change this cap, change this cap, change this cap, change this cap here, and change this cap here. And let's see what the difference is on the spectrum analyzer just by changing those 5 different parts. 1, 2, 3, 4, 5, and 1 piece of wire. My bad, I wanted to do this before I cut away. Make sure nobody thinks I'm playing sleight of hand with what we've got going on here. Okay. All right, so we changed out our 5 parts and 1 piece of wire. Just took a turn out of the output transformer there and replaced all the 220s. And let's come over here specifically and show what we did. We took the, as you can see down in there in the output transformer, we're looking here you guys. So we took a turn out there. We removed this 220 puff capacitor. We changed this 180, brought it down to 150, changed this up to 180, and then we came over here and we changed these 2 capacitors. Now we did not play anything with the tuning tube. We didn't do anything else. So we're going to see, I'm pretty sure, roughly the same amount of output power. But that's not what's impressive to me. So let me show you drive again. The 20 watts that everybody's used to seeing. Roughly the same amount of power, 630 or so watts. Let's go over here and let's look at this. Let's zoom on in so we can make it all viewable for my guys that are looking at this in 4K. Amp off, pardon me. Wrong switch. Amp on. That's just the, that's our principal frequency. Amp on. Night and day difference. Now we're all on frequency. So we're not going to have, 300 watts, 400 watts of reflect, 500 watts of reflect. See what I'm saying? Now, if you remember where we were at, to where we're at now, we've got probably 95, 96% of this on some sort of usable frequency, compared to maybe 20% as before. Now, what we've got to go find is why are we so low in power output? This should do 800 at a minimum, 950 to 1200 watts peak. We're several hundred watts low. Several hundred watts low. So I just want to show you that, you know, and I'm sure what we're going to have to do is we're going to have to bypass this 50 ohm voltage divider, 5 watt 50 ohm voltage divider. Get rid of that. I'm sitting here thinking about the electrical principles of this piece of coax, but that's, nah. We're going to have to go look at a couple different things. But just having 6 wrong parts in your box in the wrong place and the wrong number of turns can cause catastrophic failure when it gets out there in the real world. So let's go find those lost watts. Can you tie them in a knot? Can you tie them in a bow? Can you throw them over your shoulder like a continental soldier? Do your boobies hang low, 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 low? Principal? Amplifier. Hello, hello. Okay, so. Hello, freak bitches. Hello, audio 1 2 1 2 1 2. Big DC out there, about 500 watts or so, 400 watts or so. Our dead key back down again. Hello, hello, 1 2 1 2 1 2. I hate guys when they key up and all they show is a bunch of swing. Look, I had problems. I'm not gonna lie. I had to think long and I had to think hard about it. It took me back to when I was 13, 14 years old, and neighbor boy brought over his very first Playboy, and I was like, ooh, boobies. Magic sauce on this particular build ended up being I needed to add about 5 puffs worth of capacitance on the output tune. And then I got rid of the 330 on the input, got rid of the voltage divider. Now it does create a slightly, and I mean very slightly, cleaner signal with the voltage divider in there. But it does produce about 400 less watts. So I was like, nah, take it out. The other thing is that there was a 1000 puff cap on the output transformer over here, which you'll remember is actually, it was sitting more like this. And I'll replace that with a 720 puff. It's the closest to the 680 I had. 720 puff. And, well, now, do your boobies hang low? Do they wobble to and fro? About 400 bird-ish, and roughly 1000 peak. And it doesn't look like the evergreen forest on the spectrum analyzer anymore. So, and then we got rid of the big toroidal combiner, this thing here, and we reused the wire. So we got rid of this much induction. Actually, all these pieces combined. Went to a little bit more traditional 2-to-1 instead of a 7-to-1. And we're running. And you're not going to have any reflect issues anymore, Mr. P. So at the end of the day, the moral of the story is this. I'm not here to say anything negative about anybody, nor do I want to start today. I'm just grateful that I have the work to do, and I'm glad we were able to help this guy out. A good friend. This guy is my friend. He's been here to see me half dozen times. I enjoy getting to spend time with him, and I appreciate you leaving this thing here for so long, letting me take a look at it and be able to work through it in my own pace and not try and jam it into one of the party weekends when you show up and we hang out for a couple days. So this is done. The only thing I got left to do is lock down that tuning tube in the back, which I will do with some very heat resistant capped on tape, which I'm a big fan of, and everybody I know that goes and uses it becomes a good big fan of it. I'm not a fan of the hot glue. Maybe a cold day in hell, my balls will have to shrivel up, my ding dang's gonna have to fall off before I go and smear hot glue all over the outside of a tuning tube. So they make tape for that, and they make very, very appropriate tape for that. Developed by NASA, believe it or not, in 3M. So, gentlemen, I got to run. I got a bunch of other things I got to do this weekend. Very busy week coming up next week. I will be away taking care of the other business, so I'm going to probably do 3 or 4 more of these videos and then have them piled in the computer. So I'll be releasing them as we go through next week. There'll probably be no videos coming up. Let's see, today is what? Today's Friday. So, no, it's Friday. No, today's Thursday. Shit. Today's Thursday. Anywho, we're going to let these out slow. I'm going to be releasing them to the customers, so you're going to see some views before you actually, it is what it is. Be lots of content coming out for you this next week. I am working on a 24 pill at the moment for my buddy James, where we're taking 2 amplifiers and kind of mushing them together in the same cabinet. That'll probably come out next weekend, and yeah. Gentlemen, thank you, every single one of you that's tuning in to watch the video. I appreciate you watching. I appreciate your support by watching. I appreciate the thumbs up. Yeah, I'm just grateful to be here. I want to thank Mr. Black Productions for putting up with my horse shit and always listening to me and being willing to support me at every turn in this little adventure. Thanks Excess Power for your batteries on the workbench. Thank you Siglent for letting us have the wonderful technology that we used in this video this evening. And as always, thanks Bird and Coaxial Dynamics. Gentlemen, I gotta run. I'll see you. I'm gonna go do some other stuff, like maybe sleep for a few hours, and gotta get up and come back out here for a minute. So on that note, we'll see you. Bye.